History of aviation began with the Wright brothers, passed through the Mustang and Spitfire, and reached orbit with the SR-71 and B-2. But now a new era is beginning, an era where speed, stealth, and artificial intelligence decide the fate of nations. 3 projects are entering the stage that can change the rules of the game. SR-72, a lightning bolt that tears through time. B-21, Raider, a shadow that disappears from radar. F-47 NGAD, a brain that commands swarms of drones. These are not just aircraft. They are 3 strategies of war: breakthrough, disappearance, and total control. Each has its heroic moments and its weak points, from engines to logistics. But here is the main thing. What wins the war tomorrow does not necessarily win it today. So, who will dominate? Speed, invisibility, or the mind? Brace yourself. The most interesting part begins now. To understand modern projects, you have to look at the past. The SR-71 taught the world to fly fast and far. The B-2 showed how to hide, and the 5th-generation fighters began to think in networks. The F-22, F-35, the first attempts to combine a pure aircraft with a digital ecosystem. What we today call NGAD or B-21 is the logical continuation of this evolution. More automation, more integration, more focus on how a platform works within a system, not by itself. SR-72 is not just a project, but an ambition to create an aircraft that moves several times faster than sound and can cross an ocean in the time ordinary planes are still gathering data. Its concept is a hypersonic reconnaissance platform with a declared speed of over Mach 6 and minimal reaction time. Imagine a vehicle that can simultaneously evade interception and deliver intelligence, or even a strike payload, to places other fighters simply cannot reach. But behind this dream stands a series of serious challenges. First, the engines. Such speeds require hybrid power plants, a combination of a turbojet engine with a ramjet or a rocket booster. All of this operates at the limits of material capabilities. Second, the temperatures. At Mach 6, the airframe heats up to thousands of degrees, so conventional metal would simply melt. New ceramic and composite coatings are needed, and they are only now undergoing testing. Third, controllability. At hypersonic speeds, conventional aerodynamics no longer works. The aircraft must rely on complex control algorithms and entirely new engineering solutions. That is why the SR-72 remains a concept, not a finished combat aircraft, but a direction that opens the door to future technologies. It is more of an experiment than a platform ready for serial use. And although the idea looks extremely attractive, its implementation will require many more years of testing and massive investment. B-21 is about stealth as the art of disappearing. Not sci-fi invisibility, but engineering precision that allows an aircraft to slip through layers of air defense where others already turn into fireballs and strike deep in the enemy's rear. The flying wing concept, large internal weapon bays and meticulous attention to seams, gaps, and materials, all of this is not for looks. It is for missions where mistakes are simply not allowed. What is known about the B-21 now? It is a unified blended wing fuselage design optimized for minimal visibility. Its estimated cruise speed is around Mach 0.8. Its internal payload capacity is roughly 10 tons. Projects of this scale always put pressure on budgets. Expensive materials, specialized stealth coatings, and the complexity of integrating autonomous systems all multiply the cost of each aircraft. Add to that the high level of secrecy. Most technical characteristics remain unknown. So even experts have to make assumptions based on minimal official information. A single aircraft on its own is an extremely expensive, unique asset. But a full squadron becomes a strategic force capable of truly shifting the balance on any theater of operations. F-47 is not just a new fighter, it is a concept. One brain, many hands. NGAD approached aviation differently. Instead of trying to create one perfect aircraft, it aims to build a platform that becomes the center of an entire network. Here, the pilot doesn't just fly the aircraft. He manages the information space, coordinating drone swarms while artificial intelligence helps make decisions faster than the enemy can even understand what is happening. The philosophy of the platform is built on several key principles. First, networking. The F-47 must live in the cloud, receiving updates directly in the air. Second, close integration with UAV swarms that extend its sensors and strike capabilities, multiplying the effectiveness of a single aircraft many times over. Third, deep implementation of artificial intelligence, which takes over navigation, analysis, and tactical decision-making, from filtering data to suggesting optimal maneuvers in real time. All of this happens under heightened secrecy. The program is accompanied by appearances of mysterious X-planes, experimental prototypes, and rumors of closed test flights, which only increase the intrigue. But NGAD also has a problem. It is incredibly expensive. The platform requires not just the aircraft itself, but an entire ecosystem. Support drones, secure satellite channels, cyber defense, electronic warfare systems, and massive infrastructure. If this network works, one F-47 can replace dozens of conventional aircraft. If it doesn't, it's just another expensive fighter. And this is where it becomes clear that comparing aircraft individually no longer makes sense. It's important to look at the doctrines behind them. It's not just about which aircraft is better. China is betting on mass and range, many J-20s, the upcoming H-20, wide air presence, and constant pressure through numbers. The United States is moving in the opposite direction. Fewer platforms, but deep networking, artificial intelligence, and technological superiority, with the B-21 and F-47 as the core of future air operations. In fast, pinpoint engagements, where seconds matter and a target must be hit before the enemy reacts, the advantage may be on the side of those who think faster. In this niche, the F-47 with AI support and drone swarms looks like the favorite, but in long campaigns, where continuous patrols, exhausting the opponent, and the number of aircraft in the sky are critical, the advantage shifts to mass. The verdict, without fanaticism, is simple. Victory will not automatically go to technology or to quantity. It will go to the side that can build a complete ecosystem: logistics, communication, repair lines, personnel training, AI integration, satellite channels, drones, and weapons. So we stand on the threshold of an era where the sky is turning into a digital battlefield. And in this drama, there will be no single hero or absolute winner. Ahead lies a series of real tests, engagements, trials, decisions made in uncertainty, and hangars full of new machines. And when you look up at the sky next time and see a strange shadow, remember, those are not just aircraft. That is history being rewritten right now.